Some cars needed to be waxed before they were sent to the showroom. All cars were identical except for their colors. Some were blue and some were gray. There were 3 times as many blue cars as gray cars that needed to be waxed. A number of employees were assigned to the task of waxing the cars. All of the employees worked on the blue cars during the first half of the day. In the second half of the day, only 1/3 of the employees worked on the blue cars. 6 employees went home because they were sick, and the remaining employees went on to wax the gray cars. It took 1/3 of the employees the second half of the day to finish waxing the blue cars. The employees who went on to wax the gray cars took the second half of the day to finish waxing the gray cars. How many employees were there originally, including the 6 employees who waxed the blue cars for the first half of the day? Assume all workers work at the same rate when they work. Also assume it takes the same amount of time to wax each of the gray and blue cars. This is a fairly challenging middle school problem. The reason I'm going to call it a middle school problem is because you only need arithmetic to solve the problem. I'm going to solve this problem visually. You don't need to know much beyond 7th or 8th grade math to handle this problem, even though the problem is challenging and a lot of things are going on. I'm going to solve this problem visually. So let's go ahead and take a look at the solution. What I need to do first is try to draw a rectangle that represents the blue cars, and I know the gray cars would be 1/3 as many as the blue cars because the blue cars are 3 times as many as the gray cars. So if I can represent a rectangle that would represent the blue cars, I would be in good shape. So in order to draw a rectangle that would represent all the blue cars, I'm going to start with this line. That helps me a lot. It took 1/3 of the employees the second half of the day to finish waxing the blue cars. So I'm going to pretend this rectangle represents this rectangle. I just arbitrarily chose a rectangle, represents what 1/3 of the employees did in half of the day. All right. Now remember that all the employees worked on the blue cars the first half of the day. Only 1/3 of the employees worked on the blue cars the second half of the day, and they wrapped it up. So if 1/3 of the employees can do this much in half a day, all the employees would be 3 times as many. There are 3/3 in one whole. They will do 3 times as much. Once again, if 1/3 of the employees in half a day can do this much, all the employees in half a day can do 3 times as much. Why? Because there are 3/1/3 in one whole. So this rectangle, which is basically 4 times my original skinny rectangle, represents all the blue cars. And you also have to understand one of the key points is this, is that 1/3 of all the employees can do this much in half of a day. If 1/3 of the employees can do this much in half of a day, all the employees, which is 3 times as many, can do this much. Let's try green. This much in the other half of the day, the first half of the day. So this is the representation of all of the blue cars. We also know that there were 3 times as many blue cars as gray cars. So that tells us I'm going to cut this rectangle further into 3 pieces in this manner, like this. Why would I do that? Because that will help me find a nice representation of the gray cars. So let's go ahead and do that. And that turns out to be this. And that tells me this much is, this is what would be a good representation for the gray cars. Now, the gray cars will have 4 boxes, as we have just described. Well, now we are ready to work on the calculation. Now we have 2 good representations for the blue cars and the gray cars. We now need to find out our final answer. Now, as we have mentioned earlier, this is how much 1/3 of the employees do in half of a day. So what does this represent? So each little piece represents what 1/9 of the employees can do in half of a day. So each little piece of this large blue rectangle is the representation of what 1/9 of the employees can do in half a day, and you really have to get it. You really have to get it. So each little piece is the representation of what 1/9 of the employees can do in half a day. Now, this is 1/9, this is 1/9, this is 1/9, this is 1/9. Recall the employees who didn't go home. Now, 1/3 of the employees kept working on the blue cars. Then we were left with 2/3 of the employees, obviously. Now, 6 of these 2/3 of the employees went home. Now, the leftover employees has to be less than 2/3. These are the employees who worked in the gray cars for the second half of the day and they wrapped up. Now, this represents, again, as we have discussed, is 1/9 of the employees. So, this represents the whole rectangle must represent, the whole gray rectangle must represent 4/9 of the employees. We're almost getting there. Now let's do the math. Now, we do know that 2/3 of the employees didn't work on the blue cars. So I'm going to start with 2/3 and I'm going to subtract 4/9. Why? Because these are the people who went home, and I know exactly 6 people went home. And this is equal to, instead of writing 2/3, I can write, to have the same denominator, I can write 6/9 minus 4/9. Now 6/9 minus 4/9 is 2/9. Now, so I can conclude 2/9 of the employees went home and 6 employees went home. So this has to be 6. That is, 2/9 of all the employees must be 6. If 2/9 of the employees represent 6 employees, then 1/9 of the employees will represent 3 employees. Will represent 3 employees. 2/9 is 2 copies of 1/9, so 1/9 would be half of 2/9, or half of 6, which is 3. If 1/9 of all the employees is 3, all the employees must be 9 times 3. So 1 whole, that's all the employees, must represent 27 employees. That's my answer. There were 27 workers, and of course 6 of them went home. So my answer is 27.